Okay, so you should now accept the invite. So we will keep our video working, but we'll mute ourselves and give the floor to the presenter. If the presenter wants, you can share your screen. If not, we are okay with it. We can start.
Yeah, we're starting according to the agenda. We start with Greg and MMT. So the floor is yours, Greg.
Hi, can you hear me?
Yeah, loud and clear.
Yes.
So can you repeat if I have 5 or 10 minutes?
Got 5 minutes for the presentation.
Yeah, 5 minutes, okay.
5 for presenting and then 5 for Q&As. Thank you.
Este funciona, portanto podes pôr no lugar.
So can you validate that you can see the screen? Test 1, 2. Yeah, can you hear me?
I see it online.
Okay. Can I start or wait? So my name is Greg Agriopoulos. I'm the CEO and founder at Quantum Qualia. We're doing business with the brand name Haptikos. The project acronym we are in 6G-PATH we have a contract with is MMT, so multiplayer VR medical training with Magos Haptic Gloves, Track B, and we are working with KAU Testbed. So the project itself will create a proof of concept and showcase 6G infrastructure, how it enables immersive real-time collaborative experiences with haptic feedback and precision synchronization, meeting the rigorous demands of VR's training applications. We have an existing multiplayer module, which is utilized to allow 2 users simultaneously to connect and teleoperate. And we deploy the VR multiplayer scenario. The end application was a multiplayer application for bucket balloon postpartum placement with the haptic feedback solution we provide. This is the timeline of the project. So we started with activity 1 with specifications and design, aligning with KAU testbed, etc. Then we had activity 2, implementation and testing. We are in this stage still, so we had a delay during summer holidays for 1 month. And then we'll have support and evaluation and feedback for the remaining 14 months. Regarding the infrastructure, we had 2 setups, the remote setup and the on-site setup at KAU. During the remote setup, we were connected remotely from Athens, Greece, where our headquarters are, using 1 local computer for 1 user with Haptikos exoskeletons and the VR headset solution. And using virtual private network, we were connected in KAU testbed, and they had a local computer there to test the latency, the operation performance. And then we had the setup in KAU site when we had also a local computer with a set of exoskeletons and the VR headset, and then another solution, another portable computer as a client. The exoskeletons were optional, so the user should be view-only mode as for the application, and then the VR headset is used as well. As far as the key technical components, we provided the hardware, haptic feedback exoskeletons, a gaming laptop and the VR headset for testing and validation, and KAU provided also VR headsets, PCs to host the application, both for the client and the server, and 5G USB dongles. Also, we provided the software, the core application with calibrating and connecting the system, the Unity SDK and the multiplayer module as far as the virtual application, and the tool to capture the data and validate the data traffic. It's worth mentioning that the multiplayer module supports a robust and efficient multiplayer VR experience. There are some photos from our media from our visit in KU in May. So we tested and validated the application back then, and then worked to improve some aspects of the application after the testing. And right now we are in the final setup optimization stage. As far as the test results, we captured some data even that early from May and during the summer with Wireshark. So the results were very impressive. We had a delay like 9 milliseconds and maximum around trip time 20 milliseconds and average throughput like close to 1 megabits per second. And there are the KPIs. We had some KPIs regarding the latency, less than 40 milliseconds. And as you can see, we had achieved far less bandwidth, close to 1 gigabit per second. So we're close to this metric, and more KPIs regarding reliability, computing performance, and security, which are going to be tested in the following months. Connected users like 2 concurrent users and device compatibility. Of course, we have the realistic simulation quality based on feedback from the users, a remote collaboration success rate, and user feedback effectiveness. These metrics are going to be tested the following period. As far as the added value we provide to the project and the infrastructure, we are going to extend the testbed by testing and validating the 6G infrastructure with a demanding solution, since we need synchronized visuals and precise haptic feedback, and to showcase a medical use case for the project itself, also with the scalability potential, because the basic hardware infrastructure is usable and scalable to other applications like in industrial, manufacturing use cases or others. We also integrated with 6G-PATH. We enhanced the capabilities, tested, and we're going to test also advanced options for connectivity and reliability. We also provided one set of our solution as a free for the KU testbed, and we're in discussions with some divisions within the university for follow-up projects there. Finally, we foster industry transformation, resilience and transformation and sustainability, combining 6G, VR, XR, and haptic solution, which is a missing key element for intuitive remote collaboration, not only for XR, but also to be applicable in robotics domain. And during the support and evaluation period, our solution is going to be tested and validating, including feedback for future improvements. This is our core team. We are very active in EU cascade funding projects. We have won more than 20 contracts from different projects and applications. We have 2 very active and very efficient management team members, and also a very highly experienced technical team with experience in haptics, software, extended reality, and project management and production. Thank you very much, and available to be connected with you after the presentation or any time. Thank you. Any questions?
Sorry, I was saying thank you very much for this detailed presentation. So I have 2 questions. So one is, so if you have to highlight a couple of reasons why you need 5G or beyond 5G technology for this use case, what would you highlight?
Yeah, if we speak about virtual reality applications in specific, medical or surgical training is a topic that is of high impact in the market, because you can understand there are areas that people need to travel to get a specific knowledge or experience from experienced doctors. There are other areas of the world that this level of experience is not even locally, so people have to travel abroad, etc., or not travel or do not have the capacity to get this experience or this knowledge for medical surgical training. So establishing a 5G or 6G connectivity for such an application is crucial. So you can imagine you have a doctor experienced doctor in one place of the world, and the less experienced or even junior doctor in another place of the world, and they can join in a virtual room, combined anytime. And the one could be a view only, like learning the environment, and the other should be the one providing the skills or the capacity to learn. So remote collaboration, remote training, and knowledge transfer, these are the highlighted keywords.
So, but now let me do some tough question. So, why not use just Wi-Fi at home or in the office, and to enable this use case? Because from I see from your pictures, most of the devices are actually Wi-Fi. Do we need 5G networks?
Yeah. First of all, you need in case over the Wi-Fi, of course, you can use it. But imagine you have a doctor that is highly skilled in a specific, let's say, operation. We have use cases, and I can show you some videos. So the doctor could not be available in a local infrastructure, or even the trainee could not have available landlines like 5G, like Wi-Fi. So the best alternative is to have a network connectivity over mobile communication.
Yeah.
You can imagine that this could be in developing or undeveloped countries. So landlines are not available. So this is a very good alternative.
Yeah, I think at least for this project, it's really important to highlight those scenarios and not to be open as in the discussion. Okay.
Yeah.
One thing that we are also interested is the feedback on the 6G-PATH integration and how it went. So I'm not going to ask now many details, but do you have any quick comment for this or?
Yeah, it was really good for us, really smooth, because the multiplayer module we have available was really easy to use, and we just wanted some local IP addresses, so the integration was really smooth. I will be able to provide more feedback and more details after the testing, because this month and the next month, this is planned to be tested in high details and get more metrics about the potential latency, potential usability, etc.
Okay. Did you integrate properly with all the monitoring aspects of the platform? So all the measurements and everything are being properly recorded in our platform and visualizing them. Is this already done?
Yeah, we have partially done that because the detailed testing is underway right now. We had some problems with finding some local workstations to test it, but this is underway now, so not fully 100%.
Okay, good. Those are some of our priorities. Thank you very much. So we need to go to the next presentation.
Thank you. Bye-bye.
Thank you, Greg. So next we have one with the intentional project. You can see your screen, full screen, a little straight. So 5 minutes or so for the presentation. Thank you.
Yes. So my name is Juan Berenes. I'm here to represent Nexos, to present the intentional open call. Basically, just to go straight to the point, the scope of the intentional is to add some intent management capabilities on top of the Orange testbed, basically enable the user-friendly and fast specification of intent, covering the assurance of the service and the provisioning. I'm not sure for the network slides that are provisioned. As you see here, this is the original proposal architecture that we conveyed, let's say, during the proposal time. What we did in this first month was that we covered the design and implementation of the three main software components, namely the intent interpreter, the intent manager, and the TMF adaptation layer. And we have deployed and integrated this already into the auto management testbed and integrated with the auto management platform. So let me just this is a kind of an overview of the software components. I'm not going to go into detail into each software, but we have followed a microservice-oriented architecture for all the software that we did. First of all, we have the intent interpreter, which is the entry point to our system, the one that has the graphical interface to enable the specification of the intents through the typical chat box that you see nowadays. This intent interpreter uses Spring AI to basically get, let's say, the translation of the user intent in natural language and format it in a standardized manner, considering the service specification and the service context in order to extract what the user at the end finally wants. We have an iterative mechanism in there embedded in this intent interpreter to progressively refine the expectations that are needed from the user. And since we are using Spring AI, we have native support for OpenAI, Gemini, and all the well-known LLM public algorithms. And then just behind the intent interpreter, we already delivered an intent manager, which takes care of the translation of these TM forum formatted intents and basically determines which are the vertical applications and the network slices that need to be provisioned in order to fulfill the user expectations. This component also takes care of the lifecycle management of the intent, going through the different phases of validation, fulfillment, and assurance. In this case, in the latter case, interacting with the existing closed loop governance that the Orange testbed already has, to deploy some closed loops that take care of monitoring the network and taking the corrective actions in case we see that there is something going on with the slices or anything that could prevent the fulfillment of the intent expectations. Then we also added a TMF adaptation layer. This also gives or enables TMF-based APIs on top of the existing software solutions in the Auto testbed, namely the TMF 633, which has catalog of service specifications, which we basically obtain from the vertical applications that are available in the service orchestrator available in the Orange testbed. Then we also added the service ordering and service provisioning components proposed by TM Forum, namely 640 and 641, which are also, as I said, integrated with the testbed. So whenever we receive a service provision request, this is forwarded to the service lifecycle management capabilities of the Auto testbed to provision the vertical applications. And the TMF 9.4 slice activation is integrated with the slice manager from Oro, so that whenever we receive a slice activation request, this is automatically forwarded towards the slice manager. It's translated and forwarded. This has all been integrated into the Auto testbed. It's available in a virtual machine and already deployed as containers there. So this everything is all available. Just to our view of the achievements that we covered in this phase, the activities planned for this month were focused on the development and design, development, and integration of the components. As I said, we have already deployed this into the Auto testbed, and through this we let's say enable the 4 more standard open APIs, the ones I mentioned before, from TM Forum, plus one internal that we use to capture the network intent based on the 3GPP. We deployed 3 main software blocks, but as you saw also in the picture, each of these software blocks has several software components inside. So we more than cover the original KPI that we targeted of streaming software deployed there. And we are our software components, the one that we have provisioned there, are integrated with the auto test management and orchestration platform. So namely the service orchestrator, the slice management, and the closed loop governance that was all ready there. This means that we have already achieved all the milestones that we had for this period, and that's basically it. From my side, well, just a recap of who we are. NextWorks is an SME in Italy. We and the team that we are mostly work on. We are working on all the orchestration-related research projects and so on. Our team is Giadalandi, that you probably know from our projects, and myself, and Michael and Matteo, which were taking care of the development of the software, particularly for the LLM and the knowledge graph and so on. Just let me anticipate one of the questions and give some special thanks to our team. They helped us a lot during before the summer break with the integration activities. We had a really good support from them that allowed us to finish with these integration activities on time as it was planned. So let me thank you all of them, Marius and Katalin and all the other team. That's it from my side. I don't know if there are any questions.
Thank you very much. So I've been following this project very closely with Johan and our team. So I don't have actually any questions for you guys. We will be discussing some next steps together with Johan and our team next. But for today, I'm happy. I don't know if anyone else has any question. No. So if not, I think we can continue to the next presentation. Thank you very much.
Thank you, Juan. So following intentional, we have Marcos with the CITYSENS project.
Just one moment, please, to share my screen.
Of course.
I cannot find the share. Share here. Okay. Window. Just one moment, please. Okay. Okay. So my name is Marcos Anastasopoulos. I'm here to represent the CITYSENS project. CITYSENS project is an open call project that has been led by Institute of Accelerating System and Applications, which is a research institute of the University of Athens, and also Babylon, a spin-off from Eurecom. In a summary, the main objective of CITYSENS is to provide a set of tools, components that can be used to automate the provisioning, deployment, and management of network slices and services. It provides a set of features. This includes the ability to instantiate a variety of 5G deployment options, for example, to create different network slices with a variety of sophisticated topologies. The second pillar is the ability to monitor all the components of the system and also their performance and the services that are provided over these. And all this information is collected and enhanced using intelligent optimization algorithms that can provide not only predictive but also prescriptive analytics, which in their turn are fed into the top layer, the OSM, the management network orchestration layer, which is of course responsible for the full lifecycle management of the whole system. So we collect statistics, we process them, we calculate some prescriptions, and then we apply them, creating a closed loop operation for the whole system. If we would like to see how this is placed in the CITYSENS, in the OTE testbed, which primarily the objective, the target testbed for CITYSENS, we have extensions for the core network, as we have introduced some additional core network solutions, mostly open source for OTE. We have extensions in the slice management, mostly introducing some automated and intelligent decisions there. Some extension on OSM using some enhanced automation schemes, and also extensions in monitoring tools and also testing tools. Starting from the first entity, so the main one of the first features of CITYSENS is the ability to support flexible network deployment. So we can instantiate a variety of options, starting, of course, from the baseline, the monolithic all-in-one deployment, up to the ability to have a full disaggregated solution. So here we have created a variety of network descriptions, and also virtual network function description, but also service descriptors, and also these are combined with specific link descriptions, and all these together are matched in order to create the requested network slices, the end-to-end circuit slices that will be orchestrated by Mano. The next, of course, is data collection and monitoring. So we are using standard exporters, node exporters, but also some additional monitoring entities that we have developed in order to have a complete view of the system. Now, due to scalability reasons, we have developed some custom, let's say, exporter that are used to based on some sophisticated, some algorithms relying on compressive sensing in order to increase scalability of the system. So we can monitor not only the infrastructure, but also services, and also monitor the power consumption of the whole system, which is one of the main objectives of this in order to achieve the KPIs that we have promised in the project. The third feature is related to predictive and prescriptive analytics, and I have here given an example how we utilize these measurements. So we collect all these measurements, we provide predictive analytics. Here you can see at the top left, of the bottom left, some simple network traffic predictions based on data that have been provided by OTE. In addition to these predictions, we have also made some profilings in order to see, for example, to make some experiments to see how much time is required in order to reconfigure the whole system. And based on this, all these statistics are combined and are used to feed, as I said before, the prescriptive analytics engines, which is quite important because it will give us the optimal time to instantiate our slices or to configure our topology. On the right, you can see some screenshots where we have conventional network traffic that passes through a UPF, and you can see on the bottom right what is happening when we apply the proposed configuration policy, the proposed intelligent solution that is able to predict the exact time where scale out, where load balancing should be performed, increasing performance and reducing packet drops. The fourth step, all these analytics, as before, are fed into the OSM, and these are used to create fully automated lifecycle management for the whole system. So we have the pool of resources that we have created, and then this pool is combined, is chained together in order to create this automated network infrastructure slices, supporting the logistics use case, which is our primary objective, but also other scenarios and other slices, which we will test in the upcoming in the upcoming months. Some initial evaluation results, which is, I would like to highlight one of the, let's say, important aspect has to do with what is happening, what is the benefit that we have when the proposed closed loop operations are applied in our system. So you can see here on the left 3 different policies. A policy that is, let's say, flat, which assumes that take the actions in a fixed way, applying constant values. When we have some reconfigurations that are again fixed with predefined thresholds, and also when we apply all these predictive schemes, with the gray button, with the gray colored column, and you can see that we have significant benefits when all this intelligence is combined together with the automated lifecycle management that is available, is provided by CITYSENS. Now, a brief summary of some initial evaluation results. The KPIs that we have achieved related to network function instantiation time, the number of elements that are monitored, the analytics engine, the slice reconfiguration time. Pretty much we have achieved all the objectives and all the KPIs that we have targeted. There are some additional results that we have to conduct for KVIs, and would like to do some more tests. When we introduce actual traffic from the logistics scenario and IoT traffic that is envisioned in the 6G-PATH. So this is pretty much from our side. I don't know if we have any. This is the team. My colleague Anna Janakaki from IASA, myself, senior researcher Victoria Levizaki, and also Navid Nikain from Eurecom and Babliran. Thank you. So this is pretty much what we have done. I don't know if there are any questions.
Thank you very much. Can you hear me?
Yes, of course, very well.
Okay, good. So I don't know if anyone has any questions. Okay, no. So I have a couple of questions for you. The first one is, I assume that you have validated this, and all the results you have presented, they have been done with data sets that you generate. Have you tried this with any actual vertical application that being used in real or close to real environments?
Yes, so these results have been validated, and this solution has been validated with actual traffic passing through the network, but we would like to do some more tests with additional sensors and additional devices that will be connected on it. So there are some pending evaluation results that we will be used to mostly test the scalability of the solution and how the different and of course more slices that will be instantiated on top of the solution. So currently there are some initial results with actual traffic passing through the network, but additional tests are needed in order to evaluate more results and come to more concrete solutions.
Yeah. So the goal is that we validate this in the OD use case in the project, so the industry one.
Yes, this logistics scenario, mostly IoT traffic. Yes.
But we are now starting to assess the open calls for the track C in the project. So which means we will have more projects coming that may use this solution. And my question is simple: do you think there is a lot of adaptation that you need to onboard these applications and start working with them, or is it generic enough that should be working with any application and any usage that we may have?
So this pretty much takes as input the requirements that we have from services and then instantiates the network accordingly. So in principle, we can support any service, any vertical service with any requirement that it has, provided, of course, that we have the appropriate physical infrastructures in the underlay to support this. So in principle, any service can be instantiated, provided over this. So we don't develop service, we develop, let's say, the solution, the supporting solution, the supporting infrastructure and components that can be used to provide any service on top. So in principle, we will not have any problem to operate any service.
You need to have time to retrain your algorithms, or they should already be trained, and it's just a matter of using them. That is my main question. So do you train to a specific application, or what you have should be generic enough that will work well with any?
Of course, this comes with specific traces that have been provided in the past from OT. So these are based on actual data. Of course, the retraining and the frequency will depend on the accuracy that we will have, and at a large extent on the input traffic that we will receive. So assuming that we have some type of realistic traffic, I think the results will be similar. But all this depend, of course, on the type of traffic and the type of information that will pass over the network. So this is an open question. based on the existing inputs that we have, and this is based on actual traffic provided by OTI, our actual traces. These things work pretty well, but what will happen if we change the traffic and how the models will behave, it's something that will be tested in the coming months with additional distributions, additional traffic inputs, and so on.
So as soon as we identify eventual projects that may want to integrate with your innovation, we may need to talk again and check exactly what may be needed. So the second comment, and probably to close, is this already integrated with the 6G-PATH framework? So all the measurements, it's placed in the architecture as you show, or is there still some ongoing work?
There are some additional tests, as I said before, so that we will conduct. Some initial operations exist because pretty much the solutions that were available in CITYSENS were well aligned with 6G-PATH, but additional tests are required, as you said, with more with different services, more let's say more scenarios to have a fully operational prototype, and this is something that will happen in the coming months.
Okay, thank you very much.
The baseline is operational because the baseline was pretty much similar.
I don't have more questions. I don't know if anyone else wants to do a question.
If they can share the data management plans.
Yeah, my colleague responsible for the data management is asking if you can share the data management.
The data that will be collected?
Yes.
Yes, of course. This is something that we can discuss with OT. From our side, we don't have any problem to do this.
Yes.
But this is something that we'll discuss with OT also.
Okay, good. Thank you. Anyone else? No? Okay, then we can go to the next
Thank you.
presentation.
Yes, that will be Rohit from NTUAF, and the abbreviate is. So we've managed to pick up and are now on time. It's great work. Rohit, are you with us?
Hello, am I audible?
Yes, you can hear you.
So this is Rohit Sengupta. I am Director of Research and Development for Slicefinity Limited. And we are supposed to, hello? Sorry?
I put in posting your presentation. Awesome.
Can you see my presentation?
You can see it, but not edit. No.
I can't really hear you. I mean, can you see my presentation?
Please make it in presentation mode.
Yes.
Can you make it presentation mode?
Yeah.
Yeah, now it's okay.
Okay. Right. So we are supposed to deliver an extension into the 6G-PATH testbed that's known as Focus Testbed. And the name of our project is Trusted Application Function to Enable Network APIs and Programmable Network. So first of all, before we look into this diagram, this is basically the architecture of our solution deployment in Focus Testbed. But before we look into this diagram, I would like to explain what was the goal of doing this extension and what is the benefit that vertical use case consumers will have from this use case. So what we have extended into the Focus Testbed are basically Camara Enterprise Service APIs. Camara APIs are basically service APIs with which vertical use case consumers are supposed to consume network resources. So the APIs that we have integrated into the Focus Testbed are quality on demand, traffic influence, and network slice booking. I mean, our platform at this point supports 24 Camara APIs, but we chose this particular APIs, keeping in mind that most of the vertical use case consumers in Focus Testbed will be of enterprise nature, which is healthcare, critical and emergency services, automobile, these kind of use case consumers. This particular thing shows us what are the technical enablers with which we have developed this solution. Network APIs. I mean, this is the core of our technology. Network APIs are specified in 3GPP 29522. What we do, we consume these APIs, multiple APIs, then we do data normalization and expose those APIs towards vertical use cases. That's what our platform does. So in terms of Focus Testbed, we have specifically concentrated on slicing, quality of the service, and mobile edge compute. The reason being, again, there are many other Camara APIs like identity verification, location. We did not do that because these are the APIs we believe will provide maximum value to vertical use case consumers. API exposure. Why API exposure is important? Because APIs or Kamara APIs or service APIs is the gateway for vertical use case consumers to consume network resources in a secure way. Now, before we get into this, like what we have done, this is basically the network diagram, as you can see. This was Focus's original testbed configuration before we deployed our extension. Then via a security as a service firewall, we have extended the network with these components that you see on the top. What we have done, our platform is sorry? Is there a question? No? Okay.
No,
so,
you can.
Okay, thank you. So what we have done, we have deployed our microservices, as you can see over here, which are talking to the Focus network over these policy enforcers, over security as a service. And then it exposes these APIs, API 1, API 2, API 3, towards vertical use case consumers. At this point, we are testing these APIs with a Swagger, integrated Swagger UI. Right? And obviously, we have some common services like DB admin, portal, FCAPS for performance management, all those things are there. Now, the value created by Slicefinity TEF for this particular use case is to basically expose network capabilities. And one more important thing is our platform is supposed to be enabling use cases in macro network, not Wi-Fi, not within a controlled environment. So that is why our platform is enforcing control over resource onboarding. This is extremely important because our platform is practical in nature. It's not a technical demonstrator. What it does is basically it assumes that the vertical use case consumers would be consuming network services in a macro network. When we talk of macro network, it's outdoors. And when we talk of outdoors, network resources are limited. Hence, what we do, we basically put an admission control into how much of these resources can be allocated to who, because you cannot go on unlimitedly allocating resources to unlimited number of users, because then there will be no SLA guarantee that can be provided. Right. If I move forward, if you look at this particular diagram, it tells you that this is the network, Focus network, let's say. This is our platform, which is essentially an API gateway. And these are the vertical use case consumers that we hope will start consuming our APIs. What are the APIs? Traffic influence, which is for edge computing, low latency use cases. Quality on demand, which is a QoS prioritization. Network slice booking, which is a SLA guarantee. Right? Now, the use cases that we foresee our platform could enable, we have created a list. This is basically based on our commercial work that we are doing outside Focus Lab. But these are the use cases you could then bring in to Focus Testbed, to 6G-PATH, to let them then test their vertical use cases. You would see remote healthcare. Now, when we say remote healthcare, it's not a hospital, it's an ambulance. Within an ambulance, there are medical sensors that require some sort of SLA guarantee for its sensors. Over-the-air automobile upgrade are some of the also use cases. Like you want to push an upgrade into an automobile when it is driving around, right? Connectivity as a service, critical and emergency services. For police, push-to-talk, automatic number place recognition, body-worn cam, things like that. Smart cities, railways, media and broadcasting. Media and broadcasting is a really powerful use case. Sports stadium and music festival, where cables, a lot of cables, thousands of cables, can be replaced by wireless connectivity. What is that wireless connectivity? Macro network over a 5G slice or a quality of service, QCI, right? This has been our testing method. How we have tested it? We have tested it, this is also, we are very thankful to the Focus Testbed actually to, so that we could do a staged testing. On the right-hand side, this was our step one, where we deployed our application in our lab only, and we connected to the Focus Lab over their security as a service using a VPN connectivity. So we were prepared well. And then we deployed our services, microcontainers, into the Focus Lab itself. So that's how we have tested it. And that's why I must say that we have faced very little hurdle when it comes to the integration. Finally, these are some of our test results. So if you look at our test results, this is the first test result, which is the traffic influence API, where we have successfully reduced latency by almost 75%. Now, I know there could be questions that why is it 15 milliseconds and not 5 milliseconds? But the point that I'm trying to make here is that if you look at a macro network, a real network, a practical network, then 15 millisecond going a latency down to 15 millisecond, even if it is not ultra low latency, will give a lot of justification for these APIs. And you can see from the network diagram how this works. For example, you are a user, you are using data, let's say, whatever, healthservice.com. right? So the job is that with this traffic influence, that particular vertical use case can shift only their proportion of the data into a edge compute. The moment you do that, you have an optimized path and your latency reduces. And as you can see from our test reports, from 90 millisecond peak, we have reduced latency to 15 millisecond peak. So that is quite a good result according to our understanding. The next, quality on demand. Now, if you look at this diagram, for the same user, imagine it's a drone. Right now, for example, we are testing a farm drone where drones are measuring some, moisture content of some farm products. So if you look at this same drone can use a prioritized green path towards an application, which is an UAV controller, for example, and the same drone can use another data towards a standard internet. This green path is something that we have created with the quality on demand API. Same subscriber, 2 path, 1 path optimized, 1 path not optimized. That is the goal. KPIs, what we have achieved, 75% improvement in latency, but this is in focused testbed, 30% improvement in quality of experience for QoS prioritization, and SLA guarantee with minimum QoS of 1 Mbps. That's network slice booking basically, right? Now, if you go to the next slide, deliveries and outstanding activities. In terms of deliveries, we have already delivered our application containers, which is deployed into the focus test bed. We have given the Swagger API testing with which you can test it. These APIs are ready for vertical use case consumption. Outstanding task. There are some configurations that are required in the radio network of 6G-PATH. 6G-PATH representatives would know this.
Sorry. Can just wrap up because you are already over the time.
Right. Okay. I'm actually done. Yes. Any questions, please?
Okay. Thank you. So very good and detailed explanation. I have one question. When you presented the results, the KPIs that you measured, so to be honest, for me, it seems that all these KPIs are from the network, and this doesn't make any difference if we are using your innovation or not. So if they do manual configuration of the priorities, right, or they use some other API to do it, these are the KPIs you measure from them, not KPIs exactly from the part of your innovation. Or am I saying this wrong?
No, you're right. I mean, we basically concentrated on measuring KPIs from the use case experience perspective. So these APIs were measured on the device side. So we use iPerf. So we installed iPerf on the device and we used iPerf on the web server. And then we measured the KPIs from the user perspective to basically gauge their quality of experience, because our job was also to translate into KVIs. Now, from our platform perspective, now if you say that these configurations can be done manually, true, it can be done manually. Absolutely right. But what we basically allow, if you look at this particular diagram, what we basically allow is vertical use case consumers via APIs to request this kind of configuration on demand from the network. Because you can configure this. You can configure and you can say, this is a fixed configuration. But how then vertical use case consumers will say that I have an application which is hosted on www.abcd.com. Can you provide me an optimized path for this particular application? So the idea is all vertical consumers should be able to provide their quality of service requirement to the network, and the network auto-configures this by APIs and not statically. Was I able to answer your question?
I would prefer, because in this case, we are assessing your project, not the focus test bed, because it actually is not impacted by your innovation. So I would prefer if the KPIs in this case are more related to you. So if you compare, for example, without your solution, then it takes 2 days to define the slicing. With you, any vertical application can do it in 10 seconds. Okay, I think this would fit better the purpose of the measurement. Still, of course, don't remove what you have there. Just complement it with what actually your project is bringing as a difference. Okay,
Completely understood.
That's a baseline with focus. For example, if they don't have already any API to do this, that is exposed to verticals, how would they do it? How long it would take? And use this as a baseline. And then you can also assess, okay, in a more concrete scenario, in a production environment with a telco or a private network, how would this be done in average? And with your solution, then you have an improvement of X time. So keep those ones because I think they are relevant, but don't forget the ones you also need. Okay.
Completely understood, and I agree with you. We will actually come up with some KPIs on if you do a manual configuration, how long it will take, what are the disadvantages, and this is like an on-demand consumption which can be triggered in milliseconds. Absolutely. Yeah. Thank you. One last point I would like to make is that we would like to continue innovating. So if there are 45 APIs in 3GPP specified by release 18, and our platform supports 27 Camara APIs. So if and when more and more APIs become available, we would like to continue innovating and exposing APIs to our vertical use case consumers. Thank you.
Thank you. Any other questions? So I'm getting the same question as before. So data sets and sharing them as open source. Is this something that you will be able to provide as an outcome of this work?
Could you repeat your question?
Data sets. So can you make data sets openly available based on the trials that you are doing and you are going to do next?
Yes, absolutely. I mean, what we have implemented on our northbound, if you look at the northbound of the diagram that I just showed you, what we have implemented on the northbound is anyway open source. So yes, we will be happy to do that.
Thank you very much. Any other questions? No? Okay, thank you. Let's go to the next one.
Thank you.
Thank you, Rory. Okay, so we're 4 minutes before the hour, but Carlos, 6G-PATH PLC. Yes, you're online. If you're ready, you can continue. Carlos? Carlos, after that.
Yes, hello, can you hear me?
Yes, you can hear me.
Okay, sorry, I just joined. I had a nuevo Opera Pinterco, so let me start presenting. 1 second, please. Okay, you said I have 5 minutes, so I will start right now. Basically, you already have these informations, but to explain a little bit, 6G-PATH to Valencia, we wanted to deploy and connect our testbed located in Valencia, Spain, to your framework and test some beyond 5G features for the smart cities and the education vertical. To summarize, we have in Valencia an outdoor 5G parallel network that we want to use for the smart city in the campus itself. And we also have an indoor network that we want to use for the education use cases. I also know that we have, during this time, I will explain, we already have verified that we support RedCap from 5Com devices. During this time, 5Com has developed 3 types of RedCap modems, 3 variants, all with Raspberry Pis with LAA, Raspberries with M2, and standalone boards with Ethernet and USB. And it is on testing phase. And they have been validated in our private 5G network over M40 and N78. And the results, you can see there, the KPIs in megabits per second. And the next step for 5Com is right now to develop the radar incorporated with a 5G modem that, and also in order to enrich the smart city node. Moving on to the ELCM development, we have measured some KPIs here in Valencia. Latency, jitter, uplink and downlink bandwidth, and using commercial 5G phones and 5Com modems and 5G modems. And we also integrated our Grafana dashboard with the ELCM platform, allowing the continuous monitoring and visualization of the measurements. And well, all these KPIs have been measured on both N40 and N28. The next steps we want to do is to put the two coverage tests in several places of the campus with the 5.5G models and RedCap. Different KPIs under control of the network. For example, stress in the network can see the degradation. And also, we are still missing the connection with your main front end. I hope they consume. Now, moving on to the both verticals, the smart cities, we have done some drive tests using robots and robot drones. We also done some, we have a digital twin platform in Unity where we send data from these robots. And next step will be to put these the RedCap modems in this digital twin. Also with the radars and with the sensors that we have across the campus. And for the upcoming, yes? Okay, I will continue. For the upcoming Open Call 2 projects, we would like to have solutions for outdoor navigation, data monitoring, and remote operation. We also would like to have our digital twin platform to visualize and control remote devices, and also add services for mobility, infrastructure supervision, and AI automation. Regarding the education, we already have using our laboratory for several education projects and also educational scenarios, apps, and contents. We would like to, for OC2 participants, to promote extra educational applications, use testbed equipment because we have several types of equipment such as VR glasses, holographic cabins, etc., and we would like the participants to leverage that and to prove, well, its validity. Any kind of 50 classrooms, test the 5G network, such as slicing, quality of demand, etc., and also to gather network APIs while doing so we can trace the full capabilities of our 5G network. And from my side, that is all. If you have any questions regarding how 6G-PATH to Valencia is going.
Thank you, Carlos. Thank you very much. So I believe you have already integrated completely the 6G-PATH platform. Can you confirm or identify what is still pending exactly?
Well, we have ELCM, but we still have not been able to reach your database and your central front end, as far as I'm aware. So right now, we can fully say that ELCM is working locally, but as far as I know, we don't send anything to your database.
Okay, that is normal because we still don't have the central database available. So
okay.
That will be deployed during October. So it is not. Yeah?
Central database. We just have the central access.
The central, yeah, and visualization.
Talking about the analytics component.
Yeah. So there is some discussion here, but it's difficult for you to follow. But basically, Almudena is saying that so you already have the ELCM platform, so yes. You are already able to record all the measurements and everything that is needed. The only thing that is missing is the integration of that with the visualization dashboard or experiments. So you should already be able to visualize it locally, but not it's not yet available for the third parties that will use for the track C third parties that will use the central platform for the onboarding and running the application. So that is normal. Okay. My main concern is that to ensure that you have already tested gathering all the network measurements that I believe you at least you have it here yet that is working, so that in your database and you can already go through the data and visualize these measurements, which will then be able all the applications will be able to access them through our portal. But anyway, I would recommend us to in October to work. So basically, the two track A new test beds of 6G-PATH to work directly with UMA and also with OneSource, so we can finalize the integration and we can start onboarding the new projects that are coming in December, January. Okay?
Okay, Luis, I take notes and I will tell my colleagues to focus on this in the upcoming weeks.
Because we are also doing that for our own test sets in October, so it would be nice to do it in parallel with you. We also have a couple of projects that were submitted to leverage your test set, so we will be talking with you and the other test set from track A. You guys will have to support us in the assessment of these proposals, and together with our external reviewers to do the assessment and the evaluation of the proposals, so we can then rank them and have the winning one to onboard in the test. Okay, so those are the next steps. I would say in a couple of weeks.
Okay, so Luis, this the OC2 projects, the assessment will happen in the next weeks, you have said?
Yes, so the feasibility is next week, day 3 of October, and then the full review from the external reviewers, and we will ask your support to participate also as an additional reviewer. Is going to be from 15 to 20 to 29, I think, of October.
Okay, Luis, thank you. I will tell the rest of the team.
Yeah, but Samuel and F6 team will give you more details specifically about this. Okay, but we can confirm that we already have a couple of projects for your test bed, so it's very good to know that we can continue so you have 17 proposals.
Okay,
so,
not a couple, a little bit
more than a couple.
Less than a couple.
We'll talk privately more about this. Okay.
Okay, Luis, thank you.
Okay.
And the rest of the 6G-PATH team.
Yeah, I have no more questions. Anyone else? No DMP question?
No, because the answer.
Okay, you have already answered all the DMP questions. Good. Thank you very much, Carlos. We will talk afterwards. Next one.
Thank you, Carlos. Looking at the list, yes, Juan Bautista from PITANCE. If you're online, you're the next in line.
Hello, good afternoon, everybody. Let me show you the screen right now.
That's great, thank you.
Okay, is it visible?
Yeah, that's good.
Okay. So, welcome to this midterm presentation about the PITANCE project. My name is Juan from Cubic Fort. Today what we're going to present starts by remembering a bit about the extension of the UMA testbed. Very briefly, we are implementing the possibility in the drones to automatically track the pollination of pitaya flowers, and what you're going to see next are the progress performance metrics in terms of both the artificial intelligence computer vision algorithms for pitaya flowers status discovery, and on the other side about the radio access network algorithms and the simulations we conducted previous to already validating what we achieved on field. Okay. So about the autonomous drone, we conducted several analyses of various drone models with different hardware configurations and sizes to determine the most suitable option for navigating crops with narrow corridors. As we will see later, the corridor is very narrow on site there in the Yuma site, and we need to conduct all these analyses. And also, we needed to deal with the legal restrictions that limit real-world drone testing. So we simulated environment developed in Gazebo, so that we could validate the autonomous navigation algorithm under realistic crop conditions. Finally, we simulated the environment, and it is adapted to support drone vision, which is the one currently used in the Yuma at the University of Malaga, which is going to be our next addition to the project. So regarding the AI vision algorithms, we collected samples of pitaya flowers directly from crop fields in order to build a data set for training deep learning models. We thus developed multiple data sets containing pitaya flowers and visually similar white flowers to evaluate different models, achieving high prediction accuracy. We also explored various drone models with different hardware configurations and tested their autonomous flight behavior in a simulated crop environment using the same simulator I mentioned before. And we conducted a detailed analysis of the hardware, the dimensions, and the operational behavior of a specific drone model. That it is the one that the University of Malaga provided us with, which supports advanced 5G and 6G communication technologies. Well, the impact on productivity is quite clear because it increased the pollination success rate, at least from the current simulations and tests we did. It reduced operational costs for the farmers. Of course, this is obvious. But the most interesting part here is that about the target, we reached 80% of accuracy in terms of flower detection, in particular their status by means of the AI algorithms, and the latency is reduced to 50 milliseconds. This is paired with the radio access network analysis we conducted, and the baseline was validated in the virtual environment. The next thing we will do is to validate it on field in the Yuma test. Now, regarding the network, in terms of the 5G radio access network, we implemented with Open5GS and SRS RAN. Okay, we used Serum Q to emulate the interfaces without SDR hardware. And we also validated device registration, authentication, and session setup. Everything is properly documented in a very big set of documentation. And as well, you can find that the virtual channel with adjustable parameters, the bandwidth, the modulation, the signal to interference and noise ratio, as well as the place, was everything already tested. So what we got is a radio frequency propagation study where we model with Altair, FECO, and Proman what you can see here, which is basically the site, let's say greenhouses, the trees and everything, as well as the slopes that were found there on site. We will see the real image in short. And we conducted different comparisons between the different two sites, obtaining sustained HD streaming with the eMBB budget we already had. This is the site. Okay, you can see here the greenhouse, and we also conducted the characterization of the 5G antenna, presumably to be located here, and we actually obtained different patterns for the let's say the profile of the waves submitted by the corresponding antenna. Okay. Well, this is our team. The next steps we're conducting in our project are essentially we are having an event to show on site our achievements, a demonstration of them next month of October there in Malaga. And also we are going to make a real characterization of the radio access network so that we can decouple a little bit more from the real site in terms of simulations. But at the end of the day, we are already prepared to do the demonstrations on site. And that's where we're going to put our efforts currently on the upcoming months. Thank you very much.
Thank you very much. Any questions? The same. So again, data sets. So my colleague is saying that there has been no clarification about data sets gathered and to be released publicly. Can you please give some information about this now?
Sorry, I cannot hear you very properly. You mean some information about what exactly?
Yeah, so I was saying, but I was saying that you have not yet clarified how many data sets and the characterization of the data sets that you will record from your station, and if they will be released as open data sets.
Okay, it's a very good question indeed. In fact, I can respond to the second part. They will be open. The first one, I cannot say the exact number. What I know is that we have an extensive number of resources for the data sets collected, but that is something that is during the other partner of the consortium. So if you want, I can send you an email detailing all this.
Yes, please. That would be great.
Okay.
Any other comments or questions? I know that you already have a meeting scheduled for Friday with the UMA team to clarify some aspects. Also, I assume the integration with the 6G-PATH framework is really simple in your case. So, and I know that it's running smoothly. So I have no further comments or questions. Okay?
Thank you.
Let's go for the next project.
Thank you, Juan. So next we have 6G Rescue. Thomas, are you with us? Or if you could stop sharing.
Yes. I'm here, so I will share the screen. Okay, you should see me and my slides, and you should hear me.
Check all three.
Okay, so can I start?
Yes, please. Thank you.
Okay, so hello everyone. I would like to present the 6G Rescue project. I'm Tomasz Szydło from Newcastle University, and the project vision the aim of the project was to develop an MEC extensions for ML model training, UE deployment and management. The scope of the project and the solution addresses the challenges in the deployment of edge AI. So in the ML DevOps, we have identified some challenges with a heterogeneous type of devices, the small devices, and the necessity for deploying and managing the models on the devices itself. So we are proposing some services to extend the MEC. And we think that they provide some key benefits like lack of cloud reliance on edge model training and fine-tuning, faster AI ML model deployment and updates on the UE devices, and the ML model tracking and versioning on the edge. To verify our services, to validate our services, and to properly identify the requirements for the services, we have developed the use case proof of concept application, which I will describe, and I will show how the provided services for MEC, multi-access edge computing in the 5G, 6G environment, will help are helping lifecycle of the POC application. So I will show a very simple example. The team is Newcastle University plus SME from Newcastle Spark Robotics, and the project has been validated on the Aston testbed. So Jose Calero is the testbed owner from Aston. The services that we are working in the project are, there are 4 of them, S1 to S4. S1 service is ML Compute Service. It provides computational services for MEC applications, and it provides different libraries for ML model training directly on the edge platform in 5G, 6G infrastructure. Then service S2, ML model tracking and deployment. It's based on the MLflow open source framework. Plus, we have implemented the dedicated plugins for model deployment. So I will discuss a bit more about the research challenges that we have faced during the implementation of services too. Then we have service S3 for provisioning and deployment service. So for deploying applications, I will show you where we need the service S3 in our case. And service S4 is for ML model conversion service, because we are targeting the very tiny UE devices, so we need to convert and make more less resource hungry services. So that's why we have implemented the service S4 based on our FogML set of tools. So it's an in-house developed set of tools for tiny ML models, and we have added some REST API services to use it for in the MEC application. The proof of concept application that we have implemented to validate our services, it was a rescue application. And this application just implements the scenario presented on the slide. So that during a disaster situations, a rescue team would like to use some hospitality robots at the place of the disaster. So the photos of missing objects collated by the rescue team are used to train the dedicated classifier model, and then this model is deployed on the robot itself just to identify and classify the objects in the video stream. And after application deployment, the video stream together with the identified objects are sent back to the rescue team. And in this proof of concept application, I will show you how the services S1 to S4, which is a main output of our project, are helping in the life cycle of this application. So first, service S3 is used for deploying the edge application on the UE devices. Then service S1 is used for edge application for training the model because of the set of the provided libraries and so on and so forth. So the users can provide some images to some ML processing notebooks, so they can train the models and verify, test the classifiers directly on the edge. And then services S2, S3, and S4 are used to make these models lightweight and deploy these models on the EU devices. And after deployment of this application and the models, we can observe the video stream plus the detected objects in the video stream sent from UE device through the 5G, 6G network up to the users in this area. So regarding the methodology and the evaluation, first we have implemented the proof of concept application and the services in our local testbed at the uni that was quite similar to the one in the 6G and 5G, 6G infrastructure. So we had a IoT edge and the cloud with the network between the servers. And then we have deployed the services on Aston testbed. So you can see the deployment diagram on the right-hand side. More details are presented in the report for the second report of the project, plus the virtual machines working at the edge where we have deployed our services. So you can see the photo of the Aston testbed where our services were deployed and the application itself. During the deployment, we have evaluated different parameters and metrics. So we have focused mostly on two research problems. First one, ML model training on multi-access edge versus training the models on the cloud. So we have found that training time might be quite similar on the for the small models or the model updates. It might be quite similar on the edge versus the cloud. But the real problem is with preparing the data set for training and updating the models. And in this case, sending the data from the from local computers connected to the nearest GSM station to the MEC is a bit faster than sending the data to the cloud. And we have found that it's due to the latency and the TCP slow start and the other parameters of the TCP, not to the bandwidth and throughput. So it was quite interesting. So we see the huge advantage of multi-access edge computing in this case. The second problem was related to ML model deployments to UE devices, because we have decided to expose the small ML models as Docker containers. And we have found the problem with heterogeneity of the UE devices and the Mac devices. That's why we have followed the solution of multi-stage containers where the final layers are built on the devices itself, because otherwise we would need to have the cross compilers on the Mac infrastructures, which might be quite difficult for different new kind of processors. So this is the area where we did the experiments. We achieved the KPI values as we were assumed at the beginning. So we have proved and validated all of the KPIs that we have assumed. But we think that it's a quite interesting research problem, how to deploy efficiently lightweight Docker containers on the heterogeneous type of UE devices. And we'll investigate this problem in the next phase of the project. It's towards the publication, research publication that we are started working on. So just to sum up, we have successfully fulfilled the project objectives for phases 1, 2, and 3. So we are now in the longest phase of the project. All of the assumed KPIs and KPIs has been achieved, and the methodology for evaluating them has been described in the report. And currently we are working on dissemination of the results. So first one, we are researching the other optimization techniques for ML model deployments using MEC plus UE devices. And we are started drafting the research paper with the project outcome and proposing the MEC extensions and the research findings. Yeah, it's all from my side.
Thank you very much. Any comment? Question? No, everyone is happy. So I have
a video for this will be.
Yeah, so Jose is asking some videos.
Hello, Jose. I have seen you on the camera.
So I have a few questions. First, did you assess the energy consumption and compare between processing in the edge and in the cloud? Is there some way you would be able to assess this, or not in the roadmap?
Analyzing the energy consumption was not in the roadmap of this project, but nevertheless, the problem is quite interesting, and I think that we'll try to investigate it in the research paper. So it was not in the roadmap, but I think that we'll put it in the papers just to make it more in-depth research.
Okay. We are not asking. I was actually questioning if it's something, because I do believe it could give extra insights, and for us as a project would be useful to showcase such an impact assessment on that. Then the second question is, I didn't see anywhere the impact on data privacy. So I do believe that besides those technical requirements and the characteristics and impact, for me, one of the key aspects is data privacy, how much we are not sending to the cloud, and that is able to stay in the edge and not being copied. I expect that you are not looking at this also, right?
We haven't discussed it precisely, but as you can see, I will show you on one slide. I think it's this one. As you can see, we are processing the video stream on the EU device itself, so it's on device processing. So we can identify the objects, and we can if we decide to stop sending the video stream, we will get only the information of objects detected. So all of the data might stay on the EU devices. So it was not explicitly discussed in the report of this project, but we have assumed that it follows typically, the usage of edge computing and the IoT on-device processing, that all of the data might stay at the device, and the processing is done on the device itself. So if we stop video stream, we'll have only the outcome of the models.
Okay. Even if it goes to the edge, I think it's a good boundary, and not then going to the core. So yeah, so you have a fixed edge node, right? You don't have multiple, and you don't select which one will be responsible for the training in certain scenarios based on certain requirements, right? So you don't have any management of this ML, DevOps, and things like that, or do you?
And no, as I understand your question correctly, we have defined only the services, and it's up to the owners of the infrastructure where these services will be deployed, because from the application perspective, we only need the APIs, endpoints for the services. So in our case, we had only the single services, but it's quite good research question how to, for example, compose ML compute service that might be spun on a few nodes.
Yeah, because you are assuming all the Mac platforms have the same characteristics, right? But they could have different certifications, different capabilities, and then it could be the placement and the selection, even the location and proximity could affect.
Yes.
But okay. Again, I was asking. Then I have a comment, or again, a question which is more common. You referenced that you have KPI assessment. Is this true? Did you actually query the stakeholders with relevant interest in this field, or you just measured the technical aspects with the KPIs?
In the KPIs, we have evaluated it on the test bed, and that's why this is where we have the values for KPIs.
Yeah, I'm asking about the KPIs.
Okay, KPIs. No, we have we did only we responded to the KPIs only based on the results that we have received, but we haven't done any external surveys or whatever.
Then I would prefer not to say that you have assessed the KPIs.
Okay.
Talk about KPIs. KPIs would include us, other stakeholders assessing it and giving their feedback, things like that. Okay.
Okay.
So to clarify that, I'm happy now. Any other questions? No. So very good. Thank you very much. I know Jose is really happy working with you guys, and there's a lot of things to do and possibilities for the future. So really nice. Thank you. Next one.
Thank you, Thomas. So next.
Hello, I'm Irene. I will present. Okay, so hello everyone, I'm Irene Vilà. I'm from Universitat Politècnica de Catalunya, and I'm part of the team that we've been working on TERANTIEC that I will be presenting today. So TERANTIEC calls for towards evolved 5G radio access network testing infrastructure with edge computing capabilities. And well, the main objective of this project has been, as the name says, to develop an extension of the OT testbed that provides at UPC premises a platform that is a 5G framework that supports edge computing capabilities and test a new concept that is called MEC application slices that it was introduced by ETSI-MEC, and that can be considered of the extension of network slices, but in the edge. So in this presentation, I will be covering, as requested, the progress that we've been pursuing during this project. So initially we designed the TERANTIEC platform that, as you can see here, it considers an Amarisoft equipment for supporting the 5G connectivity. This equipment includes both a G-Node B and a 5G core and a standalone. And then we could consider here we could connect to different user equipments, and then through a local area network we connected this Amarisoft to an edge server that includes it's virtualized using Docker and orchestrated by Minikube. That is a distribution of Kubernetes, and through this we can deploy different applications in the server that are deployed in what is called make application slices. Also, we can monitor in this functional architecture. It was included a monitoring part where we have Grafana and Prometheus. And then the different make application slices requirements can be satisfied by applying different Kubernetes policies to the different make application slices. Okay, so after the design of this TERANTIEC platform, we have we performed the setup and validation at our premises. So here you can see that we had the user equipment, the Amarisoft, and through a switch, the Amarisoft was connected to the edge server where we deployed Minikube, as I was saying, Grafana, Prometheus, and also for monitoring purposes also Wireshark. So we could validate all this so that to verify that the platform was working properly. In parallel to this, we performed the selection of the different applications. This was a bit challenging since we wanted to test the platform and the concept of make application slices, considering applications with different requirements, both from the radio part and also from a computational part. So we selected, as you can see here, we selected different applications that have requirements. For instance, in Minecraft, that is a gaming application, has really high requirements in terms of CPU and memory, but also other applications that are not so stringent in terms of the CPU, such as the video server. Okay, so also another requirement for these applications is that they had to be able to be deployed as in our edge server, but also be accessed by the user equipment. So after all, we selected these. These applications were deployed in the TERANTIEC platform as make application slices that were represented by Kubernetes pods. And then we also verified that these can be accessed from the user equipment. For instance, in the case of Minecraft, we could install an application in the user equipment, but for the others, we could access them through the browser. Also, for all these applications, we developed a Grafana dashboard so that we could monitor all the CPU usage, memory usage, etc. in the edge platform, and also we used Wireshark to measure latencies. Then, after validating that we could access to all these applications, we performed different end-to-end performance tests in which we measured, when we say end-to-end, we considered that the user equipment was accessing to the edge, and we considered the whole communication and also the computing aspects. So first study, we ran the different make application slices in an isolated manner, so that we could characterize what were the metrics, the performance of these applications when they were configured in different manners. So, for instance, for Minecraft, there is this gaming application. You could have different qualities. So we assess what were the resource consumption for these configurations, and also in terms of the throughput and latency that we were obtaining. Based on this, we selected some configurations that were suitable for conducting the rest of the tests, and then we obtained what were the minimum resources that we needed for these applications to run, and also to run but with a good quality. Then in a second study, we studied what was the performance of these make application slices where they were executing concurrently. In this case, we also considered that the user equipment had different radio performances. So we considered that the user was in different locations in the lab. So for this, we studied the impact of considering the quality of service class of the pods representing the make application slices, and also the priority classes assigned to each of these make application slices. With all these, we could conclude and verify that when we consider that these pods are configured as guaranteed with appropriate resource quotas, we could achieve better quality of experience and lower latencies. But it was important in this case, when configuring this as guaranteed, to configure also appropriate priority classes. And priority classes in order to ensure the availability of all these make application slices. So based on this, we could verify and demonstrate that this platform is a suitable one for studying and verifying the concept of make application slices. And now this platform is ready and available for the interested 6G-PATH partners to evaluate this concept. So, well, this would be everything from my side.
Okay, thank you very much. I expect that there is possibly one or two projects that may want to use this approach for in our track C open calls in the next phase. Do you foresee a lot of effort for the adaptation for such applications, or because I see you have used those specific applications for the testing and the training? Will it be? Is it something that it will be easy and quick to adapt, or do you expect a higher number of resources to make it work?
Okay, so the thing is that the edge server that we have here at UPC has the resources that it has. So first of all, if we want to deploy new applications, we need to make sure that this can be supported on the edge server. And also, it's important to have into account what is the architecture of the applications that need to be deployed here. So also to adjust all the management of the make application slices in terms of policy. So it's something that of course we would be interested, but we need to evaluate beforehand.
Yeah. So this is something that OT team, OT and the remaining team managing this testbed need to discuss with you when assessing the proposals we have received. So we didn't yet check how many are interested in this innovation, but we will need to cross-check with you, as I expected there's a lot of dependencies and things that will need to be checked. So So yeah, let's do this together.
Okay.
From your side, is that George? No, everything okay? Good. So I don't have more questions. Anyone else? No? Okay, we can continue. Yeah.
Okay, thank you.
Okay, so good afternoon. My name is, I believe you are seeing my screen. Good afternoon. My name is Pedro Branco. I'm the CEO of Chilby Sistemas de Información SEL in Spain. The project that we are developing is called Agriculture Network Environment for Extended Technology, or AgriNEXT for short. Basically, the objective is to extend the UMAS, the University of Malaga testbed infrastructure, via an AI, artificial intelligence-powered software tools, and also a digital twin integration. The core technologies that are being used is AI as a service at the edge, real-time 2D and 3D digital twin models, IoT sensor integration, and the sensor integration, for your awareness, are the environmental sensors that are in the fields or in the plantations at the UMAS testbed, which include temperature, humidity sensors at different locations of the terrain. And also the integration of Copernicus satellite data and also meteorological data from the governmental stations here in Spain, and also meteorological forecasts. And then optimize the data processing using the UMAS 5G and 6G infrastructure. So basically here you have, let's say, a quick schematic of the architecture. From the left to right, you have the sensors and the inputs from the satellites to the field sensors. Then we have the digital twin creation using technologies like Cesium and, let's say, open interfaces to integrate the IoT device data, or direct integration with the databases. In the case of the UMAS infrastructure is done via integration with Influx. And then the AI as a service. Then you have on the right side the client environment, which can be normally it can be a desktop environment, but normally, obviously, what we are targeting are mobile interfaces like smartphones, laptops, or even augmented reality glasses connected that are connected to the via Bluetooth interface to smartphones. And then we deliver also an online 2D, 3D digital twin. Inputs we can also deliver inputs to field assets, for instance, to automate the irrigation via the system, or to schedule the deployment of drones if required. However, this is not done, or it's not foreseen at La Mayora, but it can be done during the scalability of the system towards other actors. In terms of achievements, the core platform was developed and it was deployed. It was also integrated with UMAS environmental sensors, Copernicus data space ecosystem services, which means that we are receiving data directly from Copernicus, and also the integration with the meteorological stations and the meteorological forecast data was also performed. AI analytics were performed while integrated with live data from La Mayora plantations environment. The two deliverables that we had to submit were submitted on time. In terms of challenges, we have a challenge at the UMAS infrastructure, not related with the 5G infrastructure, but related with the size of the environmental data sample. As you can imagine, to forecast using AI agricultural outputs, you need several seasons. We only have less than 2 years of data for AI training, and also the irrigation data is measured in an irregular time frame and not with the granularity that normally is applied So as mitigation strategy, we are employing synthetic data generation in order to be able to perform the AI training. Here you see some images of the system. The data that you see is already the integration data coming from the sensors or from the live interfaces I mentioned. Here you also have the AI training interface. Here you see the digital twin. You can see the Copernicus image. You can access data from the sensors. You can also see here you have the sensor data, and below you would have you see it here briefly, the data from the meteorological forecasts from the national authorities. In terms of future plans, we have are collaborating with you while having a demonstration at an event in Malaga at the end of October in Expo AgriTech. Then in the upcoming months, we will do the system testing, performance monitoring the different KPIs related with the deployment of the platform, refinement of the platform and its maintenance. Then we also have a plan to scale this to other actors and the deployment at other agricultural environments, even because we have limited sensors at human infrastructure. So normally the clients with which we work normally have tens or hundreds of actors and much more sensors, and knowledge transfer basically aligned with scalability, discussing with stakeholders and actors in the value chain, and also towards a commercial exploitation roadmap. And that's all from my side. Thank you.
Thank you very much. So any questions or comments from the public here?
Probably they can talk a little bit more on how the 5G has helped on the particular.
Okay. So the question we have here is, can you explain how the 5G or beyond 5G technology is bringing changes and is bringing value to this?
Yes. Okay. At the moment, we are still in early stages. Okay, but let's say the concept behind is that, first of all, the type of clients that we are addressing, normally, like I mentioned earlier, they have large properties with hundreds of sensor nodes or tens, sometimes even hundreds, with thousands of sensors, and the data involved is, let's say, supplied every 15 minutes. It has to be processed and sent to technicians in the field or production managers. So this normally involves, let's say, somewhat large amounts of data. We are also demonstrating mobile interfaces where you can see satellite imagery integrated with the sensors, and also augmented reality devices, which means that, again, you have relevant amounts of data flowing, because you have the imagery like you see here, you have the satellite imagery too, plus the sensor data. So, and we are deploying this in real time. So the idea is that a user is in the field, either with a smartphone or with an augmented reality headset, like a production manager, and he has the perspective of all the field. Okay, even if the test bed is relatively small, keeping in mind that in terms of scalability, imagine a property with 100 hectares where an individual is able to monitor the entire property, the machinery, and all the assets in the property. And that's the concept, and that's where the 5G will fit.
Yeah, just making a very bad comment. Just to have your question is, I've seen all of this with Wi-Fi. Why do we need 5G or beyond 5G technology?
First of all, with Wi-Fi, okay, here we are talking about having an infrastructure that already exists on site, okay? But in fact, with Wi-Fi, you have to deploy additional infrastructure. And I can tell you that even in most of the sites where we have clients, 4G is as a minimum or exists, and 5G exists, okay? So you have already the advantage that you don't need to deploy additional infrastructure in case 5G is widespread. And also outdoors, I would say that 5G is more effective than Wi-Fi for this due to the performance issues.
Yeah. So I'm making this question is not just to highlight something. It's just that we as 6G-PATH project, we will need to highlight this to the reviewers. So we just had our intermediate review last week. And this is something that we will have to clearly justify. And I made a similar comment before in another of the presentations. Some of the innovations we have, this doesn't fit this question, but in this one and in some of the other ones fits well. So we as a project need to answer this. So we will depend on these projects for you to tell us how can we properly answer this, okay? Of course, we will work together on it, but we also have some challenges, and I think it's common between these SNS projects to have this not as clear as we would like to, but this is why I'm already putting this question so you can, all projects can start preparing an answer to this, because for sure there's a lot of things we can highlight. Sometimes we don't see, we don't identify them on the spot, but there's a lot of things there. Almudena wants to make some comments.
Yeah. Yes, just to mention that we are looking about a funnel of 40 commitments, so already we feel this huge area. So,
okay, we have LoRa.
Sorry?
We have LoRa, we have other technologies. Wi-Fi was just an example.
If you want to visit it, they're doing uses the glasses, they need more bandwidth that LoRaWAN, so on. So
yes, that's for the glasses, but not for the sensors, except video. It's the video, drone imaging, and the fixed cameras. Okay, you need something with more bandwidth, but for the sensors that are spread around the...
But the idea is that in the glasses, you can work around the farm, and you can receive information of the sensors and also videos from...
But these images are fixed.
This is the dashboard.
Yeah, the dashboard. It's not...
The idea is to visit also the farm with the glasses.
Okay.
So you have a digital twin and you can...
In this use case?
Yeah.
Okay.
And also they are integrating the monitoring of the 5G infrastructure. They put also in the dashboard, they have the sensor, but they will have the information about the 5G infrastructure to check the availability of the 5G connection. So this is, they are integrating, it's a reflection for integrating the monitoring of the agriculture sensors and also the 5G nodes deployed to see some of them has some failure.
As I said, for sure there was a lot of nice things to say, but we do need to compare ourselves with 3G, 4G, LoRa, Wi-Fi, I don't know, whatever technology could be of comparison and give a good solution of how, and this is the key part, is how this beyond 5G technology can bring value to the vertical. It's not only if it works or not, but where is the value when we leverage this beyond 5G technology. Okay, thank you very much. Do you have any additional comment, Pedro?
Just a remark. Okay, we like I said, we can also bring this during the next phase of the project because there is a component that is commercial exploitation and analysis of all these elements. And since we work with clients in this field, we are aware of what exists, what are the needs, etc., and where 5G, 6G can be of advantage. Okay, if you need this at a specific time, we can prepare something for you. Otherwise, you will see this later in the project.
Yeah, I don't know that that is something that we need to work on with most of the projects, including yours, but also the next wave of projects that are coming. Thank you very much.
Thank you.
So, yeah.
And now?
Yeah, hi.
Yeah, okay. Lovely. So we'll resume now with the final three projects, 6G Anywhere, OAIBOX, and 6G Problem. If you really, we can see your screen, you've heard you, so feel free to start whenever you're ready. Thank you.
Okay, so may I start now?
Yeah, go for it.
Yeah, okay. So here I'm present this 6G Anywhere project. It's a Track B project to develop the infrastructure extension. And we are working on a self-powered 6G communication station with satellite connectivity. And the purpose is to facilitate anywhere deployment, especially in the places without terrestrial network and or power supply. So this is the objective, to develop a station that can be easily deployed in the hard-to-reach areas, like the desert, the sea, or the mountains, and also to offer extra bandwidth support, and also to support some on-demand B5G, 6G services. This is the framework of the 6G Anywhere project. So basically, the core of this project is to develop the 6G Anywhere station. So the station will be powered by renewables and then the battery, so it does not rely on the power grid. And also for the backhaul communication, it utilizes this low Earth orbit satellite terminal. Now we're using the Starlink. And then on this side, it offers the B5G or 6G services, the network services. And this part follows the O-RAN architecture. And with this B5G or 6G network, we can connect the terminal devices, such as this 6G CPE or mobile phones that support 5G communication. And with this CPE, we also change the power supply as this renewable and the battery. And with and then these smart devices that support Wi-Fi communication, they can join the network through the CPE, and then with the 5G communication and through this satellite communication back connected to the 6G-PATH core network. Okay. Yeah, and then this is the station that we have developed. Here you have the picture. We have the battery storage and the solar panel and the Starlink. And then in this side is the box that we developed for voltage control and then the energy management. And this part is the hardware diagram. So one challenge that we have been facing is the different voltage levels, because we are using this like the Starlink, the router, and then the mini PC, etc. So they require different voltage level. So we have designed a DC-DC converter to convert this 12-volt power supply from the battery and to supply different voltages to the different component of the station. And also at this part, in addition to the satellite connectivity and the 5G and 6G signal, with this router, it also supports the Wi-Fi communication, and we can also connect the other bridging devices, such as the LoRa or MIoT devices.
Yes, we can.
Yeah, and then for the software diagram part, all the 5G stack was hosted on a mini PC with the Linux as the operating system. And on top of that, we are using the ATUS B210 as the transceiver. So this part relies on the ATUS driver. And on top of that is the SRS-RAN open source project. And we have connected this SRS-RAN project through a VPN as a backhaul, and then through the Starlink connectivity to the 6G-PATH testbed. At the same time, we have developed the startup and maintenance script, and also the performance evaluation script. This is the CPE part. This CPE is offered by the partner from University of Malaga. And then we have also converted it. We have also changed the power supply part to battery and a solar panel. And this is the hardware diagram part, which is much easier than the communication station part. Yeah, so for integration, then this is our the integration model that we have tested. This part, we use the 6G-PATH core from La Mayola testbed. And this is our station, and this is the CPE part. Then we use the mobile and the laptop devices to test the connectivity. And for testing, this part we firstly tested the RAN connect to the 6G-PATH testbed. And after the RAN is connected, then we started the CPE, and it's also shown that the CPE successfully connected. And then with the 5G UE mimicked with one laptop and the 5G the Cactel 5G module, then we tested the round trip latency from the UE to the 6G-PATH core network. And then the round trip latency for the maximum, it has like less than 300 milliseconds. And for the KPIs of this project, the implementation KPIs, we have finished all of them. And then the remaining KPIs are the communication dissemination KPIs that we are going to finish until the end of the project. And for the next step, what we are going to do is first to deliver the system to the 6G-PATH testbed in La Mayola. And also next month, there's an event. We're going to present this project in the event. And the other one is a long-term testing and the data collection, because this project is not only software, but also hardware development. So we're also going to test this long-term stability of the system. And then the rest is the communication and dissemination part of this project. This is our team. And yeah, that's all. Thank you.
Thank you very much. Very interesting project. I don't have specific questions. Anyone else? So I've discussed this with Uma, and it seems everything is on track. I would really like to see further work on top of this infrastructure, and as I said, these capabilities and how much those solar panels can support and extend the range of the solution. And yeah, I think it's really interesting what you have, and I look forward to see the actual KPIs measurements in terms of the sustainability and energy efficiency. Anyone else? Any questions? I don't think so.
So maybe one or two comments from my side. Yeah, so thank you for your comment first. Yeah, it's true that we have not yet done do optimization of the sizing part, like how big the battery should be or how big the solar panel should be. Yeah, the other thing is like for this project, we are using the SDR. As you know, the transmission power from the software-defined radio is somehow limited. So at this moment, the transmission power is like 100 megawatt, which is a bit less. So we do have plan to further develop another one with a commercial O-RAN RU, which support up to 20 watt transmission power. So in that case, we will need to maybe redesign like this part, like the energy and the solar panel part, to check how big they should be to support the system. But at this moment, I mean, we have finished the proof of concept research, and this part of the system, we're pretty confident that it works fine. Yeah, for the future, maybe we can do more work.
Yeah, exactly. And then also test out with the geo satellites would also be interesting. Yeah, thank you very much.
Yeah, thank you.
Thank you, Yuri. So we move on to our second to last, Paulo Marcos. OAIBOX, are you with us? You are. I can see your screen and I can see you.
Hello.
Hello.
So I'm going to start sharing my screen. So I believe you can see my screen.
Yeah, we can see your screen. And we move to full mode. Just confirm.
Okay, so thank you very much for having us here. We are Always Smart, a company that is behind the OAIBOX product line. We are a company very focused on open source implementation of the 5G stack. And we have developed a product line based in an open interface that facilitates the use of the open source code. So the idea is that our customers can accelerate the research in 5G and 6G instead of using all this complexity that typically open source test beds have. And we have integrated everything in a OAIBOX that facilitates the use of code. And this is a quick video that shows how the system works. So thanks to the OAIBOX, it's possible to connect any USRP, software-defined radio from NI. The system automatically detects which USRP is connected, and the configuration is done automatically. We have a very nice dashboard that controls the system. Customers can upgrade the system to have Open RAN support, CU/DU, Open Fronthaul. Even if they want to work in FR2, it's possible to connect to millimeter waves phase arrays and beamformers to test 28 GHz band, for instance, even using REEs. In this case, we are working with TMITech. More recently, we have expanded the solution to support FR3. That is one of the 6G bands, very promising. Okay, so this is a quick overview of our products and how this is now linked with the 6G-PATH project. The main objectives of this extension is to extend our AgriNEXT City Living Lab with our OAIBOX Open RAN software modules, so the CU, the DU, the RIC, and the dashboard, and bringing additional 5G advanced open source features, improving the network performance of the open source solution that exists at Aveiro Tech City infrastructure. Then we use, to showcase the potential of this extension, we have worked on network slicing feature to demonstrate RAN sharing between enhancement of broadband and ultra-low latency, for instance, for vehicular V2X applications for this kind of vertical that requires very low latency. In terms of integration with the 6G-PATH infrastructure, so we have worked with the IT team, we have integrated with the 5G core Open 5GS, and then we are using the OAIBOX as an Open RAN solution with the DU, the CU, the RIC, exposing the metrics through the OAIBOX dashboard, but also through the experimental life cycle manager from 6G-PATH. I would like to give you a short overview of the new network slice configuration feature that was developed in the context of this project. So this is the architecture of the OAIBOX network. You have the core network functions, you have the RAN, the near real-time RIC, connect to a radio unit, and in this case you have two user equipments. So we have created an XApp. You can see here the XApp library. We have several open source XApps for our customers to play with. This is a new one, network slicing configuration. So it's quite easy to export through this portal to configure the number of resource blocks for each slice, and you have implemented the slices that has been defined in 3GPP. In this case, you only have two user equipments, one for enhancement of broadband, another for ultra-reliable low latency, but it's possible to very simple configuration to change the number of resource blocks. For instance, instead of 50, we can actually change the number of resource blocks during the runtime, and then save this configuration, and then now we have a less number of resource blocks, and then we can run speed tests and see the what's happened when you change the number of resource blocks. For instance, you move here from 80 megabits per second to 42 megabits per second. All these data are exposed through the E2 interface, but is also available on the 6G-PATH platform. So we have started doing the integration and testing indoors at IT Aveiro. here a picture with a team from Professor Susanna. Again, so working together in an indoor test bed where we have used an USRP that exists on the IT Aveiro, connect to the OAIBOX Max. Here is the 6G-PATH Experiment Life Cycle Manager, the OAIBOX dashboard, and you have two user equipment. One will be connected to the default slice service type, this is SST1, and you are going to have a device that is a Quectel modem with very demanding QoS requirements in terms of throughput and low latency. So in this short video here, we will start doing the configurations of the slices. You can see here in the dashboard, the dark blue is the number of resource blocks allocated to the Quectel. There are 217 resource blocks. We are using 100 megahertz bandwidth here. And the remaining resource blocks that are 56 are for the iPhone. And we are going to run a speed test, a simultaneous speed test. So both the iPhone and the Quectel will compete for the resources, for transmitting over the air through the radio unit that is here. Okay, and then, so let's start the speed tests. We are going to run a speed test starting with the iPhone and then the Quectel here. It's not very clear, but you see here that the iPhone has reached 140 megabits per second, more or less. And here we have already a downlink speed of 413 megabits per second in downlink. Okay, so this actually is the slice that has more resources and higher priority. Let's finish the speed test. So this is a downlink, 408 megabits per second, and uplink you have 26 megabits per second. When in the iPhone you have only 40 megabits per second. So the difference is almost more than the double performance in terms of throughput in this device. And if you look to the latency, here you can see 9 milliseconds round trip time. So latency 4.5 milliseconds. And here you have 16 milliseconds of latency. So in fact, the allocation of resources and the priority works here. And then finally, you have the connection with the 6G-PATH Experiment Lifecycle Manager, that you see that apart from the metrics for each slice, apart from going to the dashboard, they are also exposed to the 6G-PATH Experiment Lifecycle Manager, where we can see that here the metrics will be appear, all the physical air metrics in terms of key performance indicators and so on. Okay, this was the indoor testing, and then we move to outdoor. IT Aveiro has a trial license that is very useful for us to do this kind of outdoor testing. Here, working with the IT team on the deployment of a OAIBOX outdoor with an external antenna with 10 dB gain. And here we are testing coverage, and also we have tested performance for doing some speed tests. In this case, we reach 570 megabit per second in slice 1, 50 in the blink, but for the ultra low latency slice, inside the car, you have a Quectel. Yeah, we are targeting here to see possible V2X applications, but we have a latency of around 5 milliseconds. So this shows that the implementation of the slicing is working and ready for future tests and experimentation. In terms of the simulation, we have participated in the IEEE PIMRC conference in September in Istanbul, where the new slice feature has been tested and demonstrated in our booth. In terms of KPIs, they are on the report, so typically in terms of performance, speed, latency, and contributions to the open interface stack, because number of approved merge requests. So we are key contributors to the OAI code. During this period, we provide 3 contributions to the OAI code related with the slicing implementation. The KPIs are related with economic sustainability, shorting 5G skills, open collaboration, because we are using open source, trust, because you can actually access to the code and see what is there, and also we did some GDPR compliant surveys in terms of user experience. Business impact for our company, the XApp for slicing, develop and validate in 6G-PATH have been fully integrated into the OAIBOX Open Run product line for our customers, and the OAIBOX will remain at ITI available as part of the 6G-PATH infrastructure for future testing and experimentation. Finally, I would like to thank the ITI Aveiro team for their support in the implementation of this project and the integration with the 6G-PATH platform. Thank you.
Thank you.
To take any question?
Yes. So actually, I don't have any question. I think it's going quite well. This project, I've been following it with the IT Aveiro team. So none of my colleagues also have any questions. And online, any questions? No? Okay, so we are quite happy, Paulo. Thank you very much. Continue the good work.
Thank you.
Next one.
Thank you. Yes. Thank you, Paulo. So last but not least, we didn't get a name from Student Cognico, but is there someone online presenting the project?
Hello. We're actually 3 people representing 6G Cognico. I will start with an overview of the project, and then my colleagues from ISI will present the experiments. So I guess you can all see my screen. Okay, so 6G Cognico is one of the 2 open calls that bring new testbeds to 6G-PATH. So 6G Cognico brings the ISI Athena testbed, which is federated with the 6G-PATH ecosystem, and will be offered to future open calls to perform experiments at Athena ISI testbed. The testbed is interconnected with the 6G-PATH experiment lifecycle management tools, and additionally, we also perform a federation with the Orange testbed. We use for this the ETSI OpenOP. This is a federation framework which we are bringing from another project, and this will introduce the possibility to the open callers to perform some cross-region experiments using Camara APIs. So these are our objectives: to federate with the 6G-PATH monitoring infrastructure, to perform an experiment on cognitive compute continuum enabler, which is one of the 6G candidate technologies supported by Athena ISI, to offer the support of multi-domain onboarding and cross-region experiments with Camara APIs, and also, of course, to contribute to dissemination and think-back creation. So for this, we are basically preparing 2 experiments to showcase these capabilities that we offer to 6G-PATH. The first experiment is intent-driven application deployment at the cognitive continuum enabler. So this is the enabler which is supported by the ISI testbed that will also become available to experimenters to perform their own experiments in the future open calls. But of course, we're also preparing our own experiment, which will also act as a blueprint. So in this cognitive continuum enabler, we will deploy some containerized services, and those services will be able to interact with the network, and we will use some LLM assisted cloud edge deployment and automated fault remediation. We have a dedicated presentation for this, where Vasilis from ISI will explain what we are doing. And then the second experiment is aiming to showcase this multi-region experimentation capability, where we are federating with the Orange Romanian testbed using the Open Operator Platform Federator. This is a software which is being implemented in standardized 6G. There, Athena ESI is a so-called aggregation node, which means that it can basically interconnect with third-party testbeds. So we are deploying the SETSI OpenOP Federation framework to Orange Romania testbeds and connecting with them with VPNs. So this introduces the capability, as mentioned, to perform some cross-region experiments through Camara. So we can basically distribute some applications in either of the testbeds and perform some cross-region experiments. So our colleague from Athena ESI will explain again, will provide a few more details about experiment 2 and what is its current status. So without wasting any more of your time, I will give the floor to the two colleagues, Vasilis and Tassos, to present the experiments. So Vasilis, the floor is yours for experiment 1.
Thank you, Kostas. Can you hear me, everyone?
Yes, please share your screen.
Perfect. Yeah, yes. Can you see my screen?
Yes.
Perfect. My name is Vasilis Agrinos. I'm an associate researcher at Athena ESI, and today I would like to talk to you about two things. The agentic fault mitigation framework and the Cloud Edge Continuum emulator that the agentic runs on top. So first of all, we have the Cloud Edge Continuum emulator. This is an emulator we built that has the capability of running multiple microservice applications simultaneously. This is done over an emulated Cloud Edge infrastructure that defines different nodes with different constraints to simulate edge and cloud environments, where edge nodes have limited resources and cloud nodes have more relaxed limits. And finally, this simulator has a spatial and app-aware traffic. This I will explain a bit in the next slide in more detail, but basically you can create custom traffic for each application and based on different edge locations from where the traffic is being generated. As you can see on the diagrams, in this example, we have two applications running, and you can see their topology on the top left, and on the right you can see the metrics you can observe from the infrastructure, emulated infrastructure. You can see the CPU utilization over time on different nodes or microservice applications, containers, the correlations between different end sites, the latency of the containers, etc. So how does the Cloud Edge Continuum emulator work? Basically, we have a work model.json file where you specify the different deployments. In this example, you can see we have two deployments, S0 and S1. In each one of those, we define the external services. Those are the services that the S0 deployment will call with a defined probability in order to simulate stochastic execution and traces. And the internal service, this is where the actual workload of the deployment is being generated. We can stress different types of resources on different degrees. Specifically, we can strain the CPU, load the RAM, the network traffic, etc. We can deploy then the application in 2 lines of code. Basically, we are given the work model.json file. And then with the additional traffic generation configuration, where we can specify the different edge sites. Specifically, we have a selection of different sites, such as urban sites or suburban sites with different times of traffic peak and volatility patterns. With addition of that configuration file, you can run the experiment. in order to produce all the results I specified. Now, on top of this, we have built an autonomous remediation and management agent powered by large language models. First of all, to check this agent, we deployed several emulated applications using our Cloud Edge Continuum emulator. We developed a number of MCP servers. Those are servers that basically let our agent live on a different location than our actual infrastructure and have a secure connection with it and verify the commands that the agent can run. Specifically, we have a kubectl MCP server, a Prometheus one, and an Istio to retrieve metrics. We've established a varied fault injection environment in order to measure the accuracy of our agent in mitigating those scenarios. Those can include node faults, container shutdowns, misconfigured YAML files for the deployments, such as misconfigured requested limits, etc. And then after that, we monitor the metrics for SLA violations. Specifically in our case, we're checking the latency. And you can imagine that if any of the above fault that I described is being injected to the system, we will have an apparent increase in the latency of the entire application. In that case, we basically an autonomous agent is created and is being given an intent and some context in order to try to, first of all, find the location of the error and then try to mitigate it. So if you see the diagram on the bottom, the first box shows a high-level overview of the architecture and our framework. We have the cloud edge and infrastructure. We run some microservice applications and to collect the metrics, as I described earlier. When we inject the fault, a warning is being generated, an intent is given to the agent, and the agentic loop starts. The next cell describes in a bit more detail the agentic loop, where the first step is to assemble the context. These are some relevant metrics that do not fully disclose the area of the problem because you don't have access to that information. Then the agent tries to create an action plan that specifically tries to give a plan to the agent to where to look, what areas might have a problem. Then the agent selects a tool and collects metrics and invokes the tools, collects results, and tries to fix the problem. If a termination is being given to the agent to generate an operation summary. Termination is only being considered if the violation have been mitigated. So as to the tools and operations the agent is actually capable of doing, those are being split into 4 different categories. First of all, planning and coordination. We have the create action plan as described, the generate operational summary. Those are basically there to make the agent more steerable and give it some more time to think instead of just selecting a tool, executing the tool, getting back the results, and doing that all over again. The agent can decide to create an action plan and move to another direction if the observation don't match his beliefs about the current state of the infrastructure. Then you can go to the monitoring and analysis tools. Those tools use the MCP Prometheus server. The agent is being able to get monitoring metrics from the infrastructure, such as CPU RAM from different nodes or containers, and also get the topology of our infrastructure.
Sorry, can you hear me?
Yes.
You need to wrap up because you were already over the.
Yes.
If you can, maybe
This is my final slide actually. So this is more or less the agent. Finally, we have the Kubernetes management tool where the agent applies the corrections that decides that should be done to the infrastructure in order to mitigate the problem. So this is all for me. I would be glad to answer any questions.
So the OpenSDK is an open source Python SDK that abstracts Camara and GSMA transformation functions across multiple S-Cloud platforms. And it integrates with different 5G core and RAN solutions. So what it actually does is it takes Camara manifests and GSMA manifests, and it can translate them excuse me. It implements a modular adapter pattern, so it can translate for every adapter explicitly. What we have done is, what is already in the project is the supported Camara APIs. They are quality on demand, the edge application management, and location retrieval and traffic influence on the adapters we supported. An example case of how the SDK would work with the Camara API call is as follows. It will receive the Camara manifest, patches contents, and it would generate the platform-specific configuration, attempt a connection to the Kubernetes cluster, and finally deploy the application. The SDK integrates Kubernetes functionalities like authentication, namespace management, resource creation, and network configuration. So here we have an example of a full application lifecycle. And what happens is that the SDK starts by configuring the adapters that are part of the underlying infrastructure. In this case, we initiate the Kubernetes adapter. It starts by onboarding the application, which registers the app in the database of the applications that are allowed to be deployed, while at the same time attaching the necessary metadata. Once the app is onboarded, it can be deployed wherever pointed by the SDK. The SDK can manage the undeployment of the application, so the resources are freed. And at last, the app gets deleted together with metadata to finish the life cycle. This is it. Do you have questions? If there is time, of course.
Thanks a lot, Tassos. So, Luis,
yeah, you are
questions?
Alive? Okay, so it's done. Thank you very much. No, I don't have any questions about the work, so we have been following it closely, so I don't actually have questions. I have more comments. So you did get 12 projects for your testbed. Okay. So again, like I talked with OPV, so we will need your support going through these proposals. 2 of them have been rejected because they don't follow the requirements. But that leaves us 10 to evaluate together to check if they fit your test beds, if they are in sync with what is needed. And I hope that at least 2 of them will each one will leverage these 2 nice examples you demonstrated. And basically, that's what I had just to discuss.
Yes, okay. This is Christos, Luis. Yes, we will do. Please send us any information that you need. Then we will discuss with you about the evaluation of the proposals.
Yeah. Samuel will follow up on that.
Okay, great.
Thank you.
Thanks a lot.
Thank you.
Thanks.
Okay. So thank you to all 12 sub-grantees and representatives for being available on short notice. We really appreciate that flexibility, and I think we're able to accommodate everyone's availability within the 3-hour slots. So I think for us today, we'll follow up individually with you as needed, as discussed, and in general for our plenary meeting today.
So yeah, it's closed. So thank you all. So we are going to close now our meeting. So for the project partners, so 6G partners, 6G-PATH partners, we will reconvene tomorrow again at 9 British summertime. For all the third parties, again, thank you very much for joining. It was really nice to get a quick but very interesting overview of all the projects, to know that almost all of them are really on track, and all the test beds owners that are working with you guys, they are very satisfied with the achievements. Of course, some of you we still have to clean up some aspects, but it has been quite fruitful, this work. Thank you again, and we can close now the meeting for today. Thank you very much.